And atoms are okay of elements, but what happens if we've got something a little bit bigger? So for instance, carbon dioxide is formed in the air. Whenever we burn anything with carbon, the carbon gets converted to CO2. If you are eating food, you're probably taking the carbon in your body or carbon in your food and you are burning it, and you are hopefully breathing out carbon dioxide. If not, you should remember to breathe. Breathing is quite important. So how do we deal with something like CO2? And how would we say take 10.5 grams of CO2 and count the number of molecules? So it turns out that the secret is not too bad. We take carbon dioxide and we say it is made of 2 carbons and 1 oxygen, and we actually know the weights of both carbon and the weights of oxygen, because a carbon atom weighs 12.01 AMU, and oxygen atom weighs pretty much 16 AMU. And so we can go ahead and we can weigh individual molecules by weighing the atoms and adding them up. So carbon weighs 12.01, oxygen weighs 16.00, and so when we add that up, we get 44.01. Now, what is that telling us? It's telling us that 1 molecule of carbon dioxide weighs 44.01 atomic mass units. And what a waste that is, because we don't weigh individual molecules very often. Instead, we know that we could go ahead and get at our balance and we could weigh 44.01 grams of carbon dioxide. And that would actually give us that same number, that magic number, Avogadro's number. What a cool dude. And here's a drawing of this very handsome fellow, which I believe is actually a caricature. I don't think he looked quite that ugly, but anyway, we think he's very cool. There's even a crater on the moon named after him. So that's at Avogadro's number, 6.022 times 10 to the 23. So we would have that many molecules of CO2 if we weighed out 44.01 grams of CO2. And of course, no one likes to actually use that number. Instead, we refer to that number as a mole. So we have a mole, which we abbreviate by lopping off the last E. So notice that's a 25% savings, is equal to 44.01 grams of carbon dioxide. So we can easily weigh our moles. So that number, that's about equal to the number of stars in the universe. We can count out that number of molecules of CO2 by weighing out 44.01 grams. So if we want 10.5 grams of CO2, I think you know what's coming up next. So here goes. We got 10.5 grams of CO2. We want to convert to moles. So we take our conversion factor setup. 10.5 grams of CO2, write it up front, and then we write our conversion factors. Our conversion factor next. So we've got 44.01 grams of CO2, which has to go on the bottom because we need to cancel out the grams of CO2 on the top of the other side. So we can pre-cancel. And the 1 mole of CO2 goes on the top. We go ahead and we do that calculation. Our calculator is very naughty and gives us a very large number that starts with 0.2385821 blah 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 blah. Significant figures, so that's got 3, that is exact. That has 4, so clearly we need 3 here. Leading zeros never count, so 2, 3, 8 is good. We lop off the 5, and if we lop off the 5, well, 5s are higher, round up the number next. So 0.238 becomes 0.239, and the units were moles of carbon dioxide. So that's how we change grams into moles. We just add up the weights of all the atoms. That gives us how many grams 1 mole is, and we use it as a conversion factor problem. So we can go the other direction as well, right? So we can convert moles to grams. So here's some formaldehyde. Formaldehyde has the formula CH2O, so it's made up of a carbon and a couple of hydrogens with 1 oxygen in tow. We count these out by weighing out the atoms. So carbon's 12.01, hydrogen is 1.01, oxygen is 16.00. And if we add all that up, let's see, what does that come up to? 16 and 12 is 28. And carry the 2, so 30.02. So what does that tell us? It tells us that 1 molecule of formaldehyde, CH2O, weighs 30.02 atomic mass units. That's relatively useless. It also tells us that Avogadro's number, so 6 times 10 to the 23, molecules of CH2O would weigh 30.02 grams of CH2O. And, oh, that's okay, I suppose. But, of course, 6 times 10 to the 23 is our friend the mole. So 1 mole of CH2O would weigh 30.02 grams of CH2O. So if we want to convert grams to moles, then that seems like the kind of conversion factor we might need. And because I'm a doofus, I actually added up the weights of CH and O incorrectly, so it should actually be 30.03. So 1 mole of CH2O, I was just checking if you were paying attention. If you were screaming at the screen, then you're actually on the right track. So it weighs 30.03 grams of formaldehyde. So maybe you want to go ahead and say, for that extra special chemist in your life, if you needed to give them 1 3/4 moles of formaldehyde, how much would you have to weigh out? So you have your choice. You can put that on the top, or you can put that on the top. So which one is it? Very good. It's the grams on the top, because we need grams to show up at the end of the calculation, and we need moles to go the way of the dodo at the end of the calculation. So if we do it this way, the moles cancel out, and we are left with grams. And again, if we go ahead and we calculate this sucker, we get 52.55. So with rounding, that would be 52.6 grams of lovely, delicious formaldehyde. And that would be equivalent to 1.75 moles. So you can see, in recap, we really just add up the weights of all the atoms for every molecule we have, and that gives us the number of grams 1 mole of that molecule would weigh, and we use that as a conversion factor. Good job.